Alright, so last we left off, we had our little guy and we got him moving around with his legs and his head and they're not disjointed. The only thing I did since the last episode was change his jumper color yet again. I figured black was more contrasting and I could just kind of see him a bit better. So I ditched the purple and we're going with black for now. But let's get this walking cycle animation stuff happening. So first I want to create a variable that basically tells another subroutine if the player is walking or not. So I'm just going to call this IsWalking. And we'll store that at a location in RAM. And then we're eventually going to be using a table to keep track of the some of the attributes of the tile, whether it's flipped horizontal or flipped vertical and whatnot. So I'm going to keep track of the frame we're on for the walking cycle. I'm just going to call this walk cycle frame. And we're going to use that later on. Okay, that's all we need for now. We're probably going to add more up here. But let's think about where we want to call this subroutine that we're about to write. So I don't really want to call it in move player, or any of the move player functions for that matter. So move player right, move player up, move player down, because the player could potentially be holding left and up or down and right. So multiple directions at once, and we don't want to call this walk cycle more than one time a frame. So let's put this after we check controllers, because then we're only going to be checking it once. So check walk cycle. All right, now we can start writing this function. I'm going to put it after we've moved the player here. So what happens in check walk cycle? First, we load IsWalking to detect if the player is walking. If the value is 0, they're not walking, so we can check the 0 flag with a branch if equal. And we'll call this exit not walking. And then we return and do nothing. But if we have taken the branch, this is where we do all the walking animation stuff. The next thing we have to do is nothing has set this IsWalking variable to 1. But if we've made it to any of these move player functions, that's where we want to do so. Because if we're in either of those, we've successfully detected that a button is being pushed to actually move the player. So in all of these, at the very end, I'm just going to load the number 1, store in IsWalking. I'll put this in all 4 of these. All right, and that should take that byte on to 1, and we should be detecting if the player is walking. Let's see if that happened. So let's open the hex editor. And this top right byte is going to be 0f. That's where we put the IsWalking flag. And let's try to see if that ticks to a 1 when I move. And it has. Although you notice it did not tick back off when I let go of the button. So immediately after we've not branched to the end, so if we are walking, we're going to immediately decrement IsWalking back to 0. I would try to show you in the emulator that happened, but that's going to happen within microseconds, so we're never even going to see this, oops, I'm clicking the wrong things. We're never going to see this top value toggle to 1 because it gets decremented so fast, but it is happening. And now we can do all the walking animation stuff. The first thing I want to do is toggle the tile from this leg tile that is both feet firmly planted on the ground to this other one where the leg is slightly up, indicating that they're actually walking. And that is tile 23 for the up leg and 22 for the down leg. Now, we could do a table, but there's a far easier method. So the value 23 and 22, one is an even number, one is an odd number. If you want to detect whether there's an odd number or not, it's just checking the least significant bit. And if you want to alter that value from even to odd, one value away, for example, 22 to 23, you would just toggle the bit on for 23 and toggle the bit off for 22. So all I have to do is load the player. What is the tile? We have to find that sprite offset. Oh, let's make an alias. It's going to be way easier. So player leg tile equals, and where is that going to be located? The tile is right after the Y position, so player Y pause plus 1. Player Y pause plus 1. So that's going to be our player leg tile. Let's go back to our subroutine. So player leg tile. And then to toggle just a single bit that we can target, we use the exclusive OR operation. And we do that with 1. And then we store it back into player leg tile. Player leg tile. Awesome. And that happens as long as we're holding the movement directions down. Unknown label 592. That is what we, player leg tile. All right, so this should hopefully work. And it is, but we have several problems because we're not done yet. So you can see, hopefully, I don't know if YouTube's frame rate is going to get this down, but what I'm seeing on my screen is the legs flickering 60 times a second and toggling those frames. And only his right leg is toggling up and down because all we've really done is flip the tile, and the tile is drawn in such a way to where that right leg is up. So step 1 complete. We can toggle this on and off, but we don't want to do it every frame. So now let's take into account of how many frames have gone by and count them and make sure that we have like a little bit of a wait period before we do this exclusive OR to the leg tile. So I want to keep track of that number, so let's add a counter. So walk cycle counter, add that to RAM. And what we want to do is before we exclusive OR, let's check the counter. So we load, oops, why am I typing player? Walk cycle counter, and we compare it with, I want to make this a constant because I want to be able to change it on the fly. We're going to call this walk cycle amount, or walk cycle weight amount. Good enough for me. As long as it's descriptive, I try to keep my labels and stuff basically telling me what they are, because if I come back to it later and I haven't really done comments, like most of these videos I have been ignoring them, I want my labels to explain to me what the code's doing. So let's add this walk cycle weight amount, and we're going to say 3 frames. We'll say 3 frames for now. Waiting 3 frames before walk cycle change. Alrighty. And if we have reached that walk cycle weight amount, we're going to break if it is equal. Oh, so sorry. If we have not met that, we're going to branch if it is not equal and skip all this player leg tile exclusive ORing. And we can just jump to a plus. Oops. And we can just call this not walking still. I'm going to go with a plus because we're going to fill this more in with other stuff. Hopefully, no, this isn't going to work yet. We have to reset the counter if we've not taken the branch. Load A with 0, store in walk cycle counter. That would have been a gotcha. Okay, so let's see if that worked. And it did not. Let's see if our counter is moving up. It is not. Oh, we haven't incremented. Duh. So before we load walk cycle counter, let's increment walk cycle counter. Yeah, it wasn't moving up at all because we didn't explicitly tell the CPU, hey, we want this thing to be incremented. Okay, awesome. So we should be able to maybe see in the hex that that counter is being altered. So that's going to be byte 11, which is here. And it is. We can actively see that it is being altered. And we can tell just by changing this wait amount to something slower. So let's wait 5 frames before we do anything. And his leg should be walking up and down a little slower. So that looks more like a proper walk animation to me. So we're toggling the tile. Now let's take care of flipping the attributes. So we want his feet to alternate from left to right. So we have to have a way to manage that. And that's where this walk cycle frame comes into play, because we actually are going to use a table now. All right. Now let's put this down here as a table. I'm going to call this walk cycle table. And this is where we're going to change the attributes. So if the index is 0, that is when we've taken our first walk cycle frame of animation and his leg moves up. So db, we're just going to go with this first leg for now, and this is going to be a 0. We're not going to do anything to the attributes. No flips have taken place. Now let me just kind of label these. So his leg is up. Oh, and I don't need a pound sign down here. Now his leg is down, which it doesn't matter what the attributes are doing if his legs are down because the graphics are symmetrical. So I'm just going to put this as 0 as well. And now this third index, this is the second time his leg moves up, so this is where we actually have to put that flip byte that we can then load and put into the attributes. So when we flip horizontal, that's the second byte from the left, and then the rest are all 0. Awesome. And then the last one, the foot is down again, so the attributes can go back to 0 because it doesn't matter. And let me label these again. This is up and flipped, or up and left, and then down again. Awesome. So let's actually put that in our function now. Let me go to where that is located again. It's right here. And I do want to kind of label this a bit better. So this is toggle leg tile. And now we want to set attributes. I'm going to abbreviate it to ATTR, or ATTR rather. Set leg attribute. And let's do the same thing we did with finding the leg tile and setting an alias up top, because we're going to be altering that value, and it's easier for our readability to just say player leg attribute and equate that to where it is located in RAM. And that is the next byte over from player Y position +1, player Y position +2, because it goes Y location, tile, attribute, X location. So player Y pos +2. All right, now we are going to set the attributes by loading Y with our index, which is walk cycle frame. We're going to load A from our table, walk cycle table, index Y, and we're going to store that into our attributes. So what was it called? Player leg attributes. And We do need to increment the walk cycle frame every time we're here. Where do I want to do that? I guess after this has been completed. Increment walk cycle frame. And we only want it ever to reach 4 and then reset. So let's load that, compare it with 4. Branch if it is not equal to plus. Otherwise, we reset that value to 0. So load 0, walk cycle frame. Oh, store a walk cycle frame. Now, hopefully, this should work. We'll see if there's any errors. There is not. Oh, and it does work. Awesome. So now his feet are going left, right, left, right, left, right. But you'll notice that the legs are fine and they look like they're walking, but his head is just kind of stationary in one spot and just gliding as if he's like sliding on ice. In reality, when you walk, your head bobs up and down. So we want to deal with the Y location of the player's head. And we can kind of do another label under here in our main subroutine and call this player bob or head bob. All right. Come to think of it, we're going to come into an issue. The way I want to try to implement this, I'm just going to go forward with what I want to do and we'll see the issue. But we'll fix it later. So I want to detect when the player has its leg up, and I want to increase the Y value of his head, or sorry, it's actually decreasing the Y value up 1 pixel. So it's moving the tile up 1 pixel every time the leg is up to make it look like he's bobbing around. So in order to do that, trying to think of the best way without using another table is let's actually look at our table because we did write it down in a more visually descriptive way. So index 0, the leg is up. Index 1, the leg is down. Index 2, the leg is up. Index 3, the leg is down. So it looks like every time the index is even, the leg is up. So there's an easy way to check if a value is even, is it's checking the least significant bit. If the least significant bit is 0, it's an even number. If the least significant bit is ticked, it is an odd number because, let's say, let's just kind of go through our index here. Index 0, and then we have index 1, that least significant bit is ticked. Index 2, the least significant bit is not ticked, and then index 3, the least significant bit is ticked. So let's just go back to check walk cycle, and in this head bob, let's load our walk cycle frame we're on. And I realize doing this now that all this overflow checking happened before, so let's move head bob before that happens. And before we increment it. And now how do we check that least significant bit? We're going to AND with a 1. And if the least significant bit is checked, it's going to render a 1, and it's not going to be even. So we branch if it is equal to, let's remind ourselves, what happens if it's even? Up. The leg is up, the bob should go up. So branch of equal, bob up. Otherwise, if we did not take the branch, there's no bob happening at all. So the standard location of the head sprite is 8 pixels above the legs. So if we want to bob it up 1 pixel, it's going to be 9 pixels above the legs. So let's load player Y pause, which is our leg position. We're going to set the carry, because we're going to subtract with carry the value of 9 and store that to the player head Y position. All right. Otherwise, we just do the standard old player Y pause, set carry, subtract with carry, value 8, and store that in the player head. Now, if this branch does not get taken and we do this normal where the head bob is in the down location, we don't want this to then run through the bob up as well. So let's kind of make a jump here. I'm just going to call it plus plus. I'm going to put it right here so it continues all the rest of the increment walk cycle, deal with resetting it back to 0 if need be. So this should hopefully bob the player's head up and down. I have no errors. Awesome. Now things look fine and dandy because the jumper is black and he's kind of conveniently on a little black stripe. But let me move down a couple pixels. You're going to see his sprites are disjointed. That's because we're moving it up 1 pixel. I've arranged these in such a way where they're pixel perfectly kind of connected to one another. I want to maybe overlap his head down 1 pixel to account for that bob. So he's overlapping in a normal standing state, and then when he bobs, they're in kind of a more traditional state where it's one tile perfectly 8 pixels away from the other tile, just so there isn't that gap and it doesn't look like his head is getting chopped off as he walks. So we're going to change this. Instead of 8 pixels up as the standing position, it's going to be 7, and then the bobbing position is going to be 8. And we also want to kind of initialize that initial location as well, because we did initially draw them when, in setup when we loaded the room. Let me find out where that sprite is located. Ah, there it is. So 78 was 8 away from 80. We're going to call this 77 instead. No, because 79, because I'm thinking of different stuff. So that should initialize him. So he's a little bit shorter, but now we have our little bob animation and his legs are moving and it works. Awesome. Now the only last thing I want to do, I can let go and there'll be a frame in which his legs are up in the air, but if I let go and the walk animation isn't doing its thing, it's never going to reset his feet back to standing. And that in reality, if you stop walking, you start standing. So let's just quickly account for that. And that should be at the very end of the check walk cycle when we're not walking. Let's go ahead and reset everything and make sure that the tiles are back to the kind of initial state. So I'm going to load 0, or we're going to reinitialize some stuff that we've used because the counter could be in odd places, the frame could be in odd places if we just stop at any moment in time. So we're going to store that in walk cycle frame. We're going to store that in walk cycle counter. And then we are going to reset the tile back to the standing tile. So load, what is the tile value? I believe it's 22 if I'm not mistaken. So load the value of 22. We're going to store that in player leg tile. And I think that's all that's needed. Oh, no. The offset from the bob is also not taken into account for. So let's try to recreate this. So you can see he's tall right now. He's 1 pixel. He's back to where he used to be. But if I keep walking, I can get it to a state where he's short versus tall. Let me try to get that. If I stop on the perfect frame. There it is. So he's in a short state right now, and he's just standing. And there's states where he can stop, and he's suddenly grows, which we don't want. So let's then just reset load player Y, pause. Set the carry, subtract with carry. The value, what was the standing position? That was 7. And then store that in player head Y. Awesome, let's assemble. Should be the moment of truth. We got our walking, animation. We can stop at any point. His legs are firmly planted, and he never randomly grows and becomes taller needlessly. So that is walking animation. I don't think I missed anything, so I will see you next video.